So as I was saying before, I got cut off. Again, just a repeat to make sure you captured everything. The chi-square will test the null hypothesis that, or I should say, the chi-square will test the null hypothesis that the proportion of outcomes within each category will not significantly differ from the expected distribution. So essentially, the observed proportions will fall within a random fluctuation of expected proportions. The part that I think I cut off was that there are different types of models for testing goodness of fit. Two most commonly used are looking at testing observed data against a uniform distribution, or and that's across all categories, or or using a known distribution within an underlying population. The chi-square goodness of fit test does look at nominal level data. And ANCOVA is also an analysis of it's analysis of covariance versus an analysis of variance. So the function of an experimental design is to essentially explain the effect of an independent variable on a dependent variable while controlling for what we look at as far as confounding effect of extraneous factors. When those factors are not controlled, the results of measurement cannot be attributed solely to the experimental treatment. So statistically, we speak of controlling unexplained variance in the data. Okay, so we're looking for unexplained variability. The variance in scores that can't be explained by an independent variable is what we're looking at specifically. So all experiments will have some unexplained variance, okay? Sometimes because of varied individual characteristics of the subjects that you're looking at, or sometimes because of unknown or random factors that may often affect responses. When we cannot control those factors by purposefully eliminating them or manipulating them, then we use principles of experimental design to decrease the error variance they cause. That's where an ANCOVA fits in. So when a research design cannot provide adequate control, statistical control can be achieved by measuring one or more confounding variables in addition to the dependent variable and accounting for variability in confounding factors in the analysis. So the purpose of an ANCOVA is to examine the differences between groups. Now let's take a look at this Kruskal-Wallis. When we're testing for more than two independent samples, we can use a Kruskal-Wallis one-way analysis of variance by ranks. So when three or more groups are compared, this non-parametric analysis of variance is appropriate for use. It's an alternative to the F-test, which is used with a parametric test. It handles ordinal level data when two or more groups are being compared, and it is equivalent to Mann-Whitney U. Next, let's look at logistic regression. So with logistic regression, it's used when the dependent variable only has two values. So it's either occurrence or non-occurrence of a particular event. Many questions of prediction or explanation involve outcomes that are categorical. So, for example, if we ask why some individuals experience recurrent falls, Um, that's this is pretty much why we use the logistic regression, where when you want to understand or look for factors related to a person maybe did or did not having a fall history, we look for factors that would be related to whether or not the patient returns to work. Or we might look for, okay, let's start over. So let's use the same example. So let's say we're looking at individuals experiencing recurrent falls. Okay, and let's say you've identified mobility and functional characteristics that could predict whether a person did or did not have a history of falls. And let's say you also want to look for factors related to a person or whether or not a person would return to work following rehabilitation. You can examine different type of physical and psychological functions as predictors for a successful return to work. In this case, you would want to use logistic regression. And this is where the dependent variable only has, like I said, two values, and that's occurrence or non-occurrence of a particular event, or the presence or absence of a condition. And it's typically coded as 0 or 1. We can't use multiple regression for these type of purposes because a categorical dependent variable would not meet the assumption of a normal distribution. So the independent variables in logistic regression may be continuous, ordinal, or categorical. And it can be run using a full set of independent variables, or maybe run using like a stepwise process, or procedure, but that's a little different. Essentially, we use this to predict the probability of an event occurring. And it's only used when the dependent variable only has two types of values. So the independent t-test is something that you might see fairly often when you're looking at research. This is a parametric test, and it's used to compare two means of two independent groups of subjects. And it's often created through random assignment. Groups are generally considered independent because each is composed of an independent set of subjects with no inherent relationship derived from repeated measures of matching. So this is one that I think that's pretty much what I want you to get out of it, that you will see fairly often, and that's pretty much what it is. It's a parametric test, and it's used to compare two means of two independent groups of subjects. Now let's look at one of my favorites, which is the intraclass correlation. So historically, to test reliability, again, we're looking at reliability, which we will go into more again in the next course. It involved using correlation coefficients, and we've talked a bit about correlation coefficients. So correlations are often limited as reliability coefficient because they're considered a bivariate, and that essentially means that only two ratings or raters can be correlated at one time. So it's not possible to assess simultaneous reliability of more than two raters, or the relationships among different aspects of reliability, such as raters, the type of test form used, or the different type of testing occasions. And this information is often important when we're looking at reliability testing. Correlation does not provide an efficient mechanism for evaluating the full scope of reliability. So the intraclass correlation coefficient is used as an index. Like other reliability coefficients, as it is a reliability coefficient, the intraclass correlation coefficient, or what we often refer to as ICC, ranges from 0 to 1. I was going to say 0.00 to 1. And it's calculated using variance estimates obtained through an analysis of variance. So there's that relationship again. And it can reflect both degree of correspondence and agreement among raters. So that makes a big difference for us. Essentially, it's used to test reliability among two or more ratings or repeated measures, and it looks at relationship and association. So may not see this a whole lot right now, but if you're looking at an article and it's talking about how they determined reliability, this may be one of the coefficients that they use to help determine that. Actually, multiple regression is an extension of linear regression that we've already talked about. The equation allows researchers to predict the value using a set of several independent variables. So it can accommodate continuous and categorical independent variables, which may be naturally occurring or experimentally manipulated. It allows us to predict a given outcome based on identified factors. So again, it's an extension of linear regression. It allows us to look at several independent variables. The dependent variable must be continuous in this case, and it's used for ratio level variables, and allows us to predict a given outcome based on identified factors. A common purpose of regression analysis could be prognostic, when we're predicting a given outcome based on identified factors, like I've said. So there was an article, Steinman and Williams, who looked at or developed a model to predict rehabilitation length of stay based on a patient's admitting diagnosis, referral source, and admission functional status, I believe. And they used a multiple regression to help determine this. I should probably also add that a second purpose of regression is to pretty much better understand a clinical phenomenon by identifying factors that might be associated to it. But essentially, it's an extension to linear regression, looking at more data. The pair t-test is also something that you will come across when you're looking at parametric test. It essentially looks at paired or correlated data. Each measurement does have a matched value, and the test looks at different scores within each pair. Subjects are compared only with themselves or within their match. And that is pretty much it for the different type of test. So everything you need to know to answer the worksheet is within this section. If you still need some clarifying on different things, let me know. I'm not going to go into detail about how to compute every single test. Again, this is for familiar can't get it out. This is pretty much so that you can be able to identify this when you see these things.